Hello everyone, welcome to the third unit of our course on techno-economic analysis in green engineering, which is economic feasibility assessment. There are in total 4 parts in this unit, and we will cover the 5 commonly used techniques that are crucial in evaluating green technologies and projects. Here's a quick rundown of those 5 measures. First, payback periods, which is the basic measures of how quickly an investment pay back in initial cost. Second, present worth analysis. This technique evaluates the total present value of a project's net cash flows, helping us understand the long-term value of investment. Third, annual equivalence approach. Similar to present worth, this method annualizes the value of cash flows over the life of the project. Fourth, rate of return analysis. This calculation assesses the profitability of investments by determining the internal rate of return. The fifth one, benefit-cost ratio analysis, which is a critical metric that compares the benefit received from the project against the cost incurred. Each of these methods guide us in making informed decisions about where and how to invest in technologies for a sustainable future. And in this part, we will focus on the first 2, payback period and the present worth analysis. Before we dive into the evaluation methods, let's discuss 2 common types of cash flows. First, loan cash flows, which involves payment of interest and principal on a loan. Such cash flow primarily satisfy the repayment requirement of the loan, typically fixed and scheduled. On the other hand, project cash flows, which is generated from the productive use of assets, including the income, cost, and the expenditure of the project. This type of cash flows is often uncertain, influenced by factors such as market demand, cost variations, and the competitive landscape. While both types of cash flows use similar calculations, loan cash flows are generally fixed and predictable, whereas the project cash flows are more uncertain and carry higher risk. In this unit, we will focus on project cash flows, but the logic and the methods we discuss can be easily applied to evaluate the loan cash flows as well. Let's start with the first economic feasibility assessment technique, payback period analysis, which is an essential initial step in project screening. The payback period is calculated by summing the expected annual cash flows until the total reaches 0, meaning the cash inflows have balanced the cash outflows. This metric is usually set by management policy and provide a quick method to filter out unviable investment proposals. For instance, a high-tech firm might prefer a shorter period to mitigate risk associated with rapid technological obsolescence. In this assessment calculation, you can opt to ignore the time value of money or consider it. The former is known as the conventional payback method, while the latter one is the discounting payback method. The traditional payback period calculation does not account for the time value of money, simply summing all cash inflows and outflows until the total exceeds 0, making the payback period. In this example, the initial investment of 1.8 million in the high energy efficiency equipment is expected to recover through the savings over a 7 years lifespan. By totaling the annual cash flows as shown in the third column, we find that the initial investment is fully recovered by the end of year 3. If the company maximum allowable payback period is 2 years, then this project would not pass this initial screening. Let's talk about the pros and cons. The conventional payback method is priced for its simplicity, allowing us to quickly sift through and eliminate projects that doesn't meet our basic financial criteria without needing extensive data. However, it comes with significant downside. It does not account for any profit made during the payback period, and it completely overlooks the time value of money, treating all cash flows as if they occur at the same time. This can lead to potentially misleading conclusions about the project's financial attractiveness. There are two hypothetical projects A and B in this slide. Both projects require an initial investment of $10,000, as indicated in the table. Over the next 3 years, each project generates different annual cash inflows. Using the conventional payback method, both projects appear to have the same payback period of 2 years. However, this method does not account for time value of money as we just mentioned. For instance, Project B yielded a significant return of $9,000 in the first year compared to Project A, which only returned $1,000. This difference highlights a major flaw in the conventional payback method. It overlooks how the timing of cash flows can affect the overall value of an investment. So in reality, in this example, Project B is a more valuable option. So the other type is called discounted payback method, which incorporates the time value of money and calculates the number of years needed to recover an investment with consideration to the time value of money. Let's look at the example, same as the one we have just saw in the page 5. But here we are asked to account for time value of money, which is assumed to be 15%. Unlike the conventional payback method that ignores the time value of money, this method adjusts for it by applying the cost of capital to the cumulative cash flows at the beginning of each period. This results in a longer recovery period, extending it by approximately 1 year in our example, where the project required around 4 years to cover its capital cost and recover the initial investment. This demonstrates how including the time value of money can significantly affect the assessment of an investment payback period. Alternatively, discounted cash flows techniques like the net present value method offer a more comprehensive analysis. We call it NPV. NPV compares the present value of all incoming and outgoing cash flows related to an investment. The difference between these values, known as NPV, determines the project's acceptability as an investment. A higher NPV indicates a more desirable investment. As shown in the diagram in this page, this method involves discounting all cash inflows and outflows. Key aspects of this analysis include determining the return or interest rate that the firm wishes to earn on the investment, refers as either a required rate of return or a minimum attractive rate of return, MARR, also commonly known as a cost of capital in the business community. The entire evaluation process considers the project's lifespan, periodic cash inflows and outflows, and the net cash flows for each period. Each net cash flows is discounted at the MARR to compute the present value. Summing this present value gives the project's NPV. If NPV is greater than 0, the investment is considered a worthwhile investment. Conversely, if the NPV is negative, the project is deemed unviable and should be rejected. Now let's revisit the same example with the same cash flow table, given a minimum attractive rate of return MARR of 15%. To know the economic value of this investment project, we need to evaluate the project net present value. The initial investment cost of $1.8 million does not need discounting, as it occurs at t equal to 0. The subsequent cost saving, considered as cash in force, need to be discounting to the present value at t equal to 0 for each year. And finally, adding these together, we find that the result is greater than 0, and we can conclude that this investment is acceptable. Okay, that wraps up our exploration of the foundation concept of the net present value and the challenge of assessing project viability using the payback period method. This is just the first part of our journey into evaluating economic feasibility. There are 3 more to come. See you in the next part. Bye bye.